Hello students, Namaskar. In our previous lecture, we have studied the transpose of a matrix and its properties. So the last property of transpose of matrices we have studied is A plus transpose of AB is equal to transpose of B times transpose of A. So first here I will verify this particular property with the help of an example, and then we will start the next topic, and that is symmetric and skew symmetric matrices. So let us first verifying this particular property with the help of an example and then moving on. So students, I am taking two matrices A and B, and then such that AB is possible to find, and then finding the product of A and B with A as pre-multiplier and B as post-multiplier, and then its transpose, and then finding B dash and A dash and multiplying them. So here I go. Students, if I take A as a matrix, and that is a column matrix I am taking, suppose 2 1 3, and B I am taking a row matrix with the elements 1 4 1. So students, since the order of this particular matrix is 3 by 1 and the order of this particular matrix is 1 by 3, so if I first of all find AB, so AB is a matrix of order 3 by 3. So here I am finding the matrix AB. Students, first of all, the first row of this one will be multiplied by the first column, that is 1. So 2 multiply 1 is equal to 2, and then first row with the second column, that is 8. First row with the third column 2, and then second row with this. So here we go. 1 multiply 1 is equal to 1 only. 1 multiply by 4 is equal to 4, and 1 multiply by 1 is equal to 1. 3, 12 and 3 is what we have got AB. Now students, if I get transpose of AB, transpose of AB is, dear students, that is also a matrix of order 3 by, since this matrix is of order 3 by 3, so transpose of AB is also a matrix of order 3 by 3. So let us find the transpose of this one. 2 8 2, 2 8 2. The first row of AB has become the first column, 1 4 1, and then 3 12 3, 3 12 3. This has been the transpose of AB. So we have found the simplest form of LHS of that particular property. The property was AB dash is equal to B dash times A dash. Okay students. So now, dear students, as we have found AB whole dash, now with the help of A we can find A dash. A dash, since the order of A is 3 by 1, therefore the order of A dash will be 1 by 3. So it will be a row matrix with the elements 2 1 3. Okay, if I find B will be a matrix 1 4 1, it is 1, and its order is 3 by 1, and the order of this one is, students, 1 by 3. Dear students, if we find, now this is B dash actually and this is A dash. Now if we find B dash times A dash, so is it possible to find B dash times A dash? Yes, it is possible to find B dash times A dash, as number of columns in B dash is equal to number of rows in A dash. So now finding B dash times A dash, and that is a matrix of order 3 by 3. So B dash times A dash is what we are going to find, students. So here B dash, this B dash will be multiplied by A dash. So first row will be multiplied by this one. So first of all 2 1 3, 2 1 3, and now second row will be multiplied by this, so this is 4 multiplied by this, so 8 4 12, 8 4 12. Now 1 multiplied by the entire row, so 2 1 3 only, this is 2 1 3. Dear students, just compare AB whole days with B days times A days. You will notice that 2 1 3 2 1 3 4 8 4 12 8 4 12 2 1 3 2 1 3. So you will notice that AB whole days is equal to B days times A days, and that is what is the fourth property of transpose of a matrix, which we have verified with the help of an example. I hope you have understood it well. Now our next topic is symmetric and skew symmetric matrices. Symmetric and skew symmetric matrices. So first of all, I will define symmetric matrix. The first definition I will define symmetric matrix. Dear students, let A, Aij, n by n be a square matrix then A is called a symmetric matrix if A dash is equal to A, that is Aij is equal to Aj. I hope you have understood. A matrix A is a square matrix. A is called a symmetric matrix if it is equal to its transpose. The matrix A is equal to its transpose. So and here that is what is written here, Aij is equal to Aji. So I hope you have understood the definition of symmetric matrix. A square matrix A is called symmetric matrix if it is equal to its transpose. So here I go and take the example. For example, here I am writing a square matrix 2 4 3 4 3, and this is 5. Suppose I taking 7 7 and 6 I have taken. Students, this is a matrix A. This is a matrix A. And now if I find this is a square matrix A of order 3 by 3. And now if I find the transpose of this matrix, the transpose of this matrix will be also a square matrix of order 3 by 3. Just find the transpose of this particular matrix. So first row of A will become the first column of A dash or AT. So this is 2 4 3. The second row 4 5 7. Here I write 4 5 7. The third row 3 7 6. This is 3 7 6. What do you notice here, students? Here we see it is clear that matrix A is equal to transpose of A. See, you can compare the elements of A and transpose of A. They are same 4 2 3 4 2. So 2 4 3 4 5 7 and 3 7 6. They are same, and since A is equal to A dash, you can write since A is equal to A dash, therefore A is a symmetric matrix. I think you have understood the definition of a symmetric matrix. A matrix A is called symmetric matrix if it is equal to its transpose. So I hope you have understood the definition of symmetric matrix. Now the second type of matrix is skew symmetric matrix. So after this, now I am writing the definition of skew symmetric matrix. Here I am writing skew symmetric matrix. Let A be a square matrix, then A is called a skew symmetric matrix. If A dash is equal to minus A or A is equal to minus A dash, means if the transpose of A is equal to negative of the matrix, or if the matrix is equal to negative of its transpose, then the matrix is called skew symmetric matrix, and it can be written as, that is, Aij is equal to minus of Aji. I hope you have understood the definition of skew symmetric matrix. Now, dear students, if I take the example of a skew symmetric matrix, then here I go. The example, I am taking a matrix A, and the elements I am taking are 0 A B, then here 0 0 C, minus A, minus B, and this is minus C. Dear students, I have taken a matrix A, and now I am finding the transpose of matrix A. Then transpose of matrix A will be, just write the transpose of matrix A. So 0 A B minus A 0 C minus B minus C 0 minus B minus C 0. I have written the transpose of matrix A. What do we notice here? Now this transpose of matrix A can be written as, transpose of matrix A is equal to, if I take minus common, or I can say this is minus, this can be written as minus 1 multiplied by the matrix is 0 A B minus A 0 C minus B minus C 0. So here students, now this can be written as transpose of matrix A is equal to, now minus 1 and times, what is this? This is matrix A, that is equal to matrix A. So you can say, since this is the condition here for this particular matrix, and therefore A is a skew symmetric matrix. I hope you have understood the definitions of both symmetric and skew symmetric matrices, and also understood the example that I took for the fourth property of transpose of a matrix, that is AB whole dash is equal to B dash times A dash.